So let's take a look at some of these homework problems. 11.7, number 22, right? They said that the two first of all, what do you know about the ABC? ABCD, I mean, is a what? It's a parallelogram, right? They tell us that it's a parallelogram. We also know the area of this is what? 48 centimeters squared. All right, so that's good. What else do we know? DE
equals 2 times.
Good. DE is equal to twice of
CE.
twice of EC. Yes. So, well, first one. Okay, if D equals twice of. Okay, can I just write 2x here and then x?
Yes.
Because I mean that's what it means, right?
That's right.
All right, good. So that's kind of important. So they want us to find the areas. Okay, A. They want you to find the area of the triangle ABE. Yeah, ABE. Do you see the triangle right here? This one. Okay.
Yeah.
So to find the area of that triangle, this one actually turns out to be really straightforward. Anybody got this one? Okay, a lot of you. Okay, how about Samantha? What did you do?
Triangle ABE
Uh-huh.
has the same height and base as parallelogram ABCD.
Good.
So you just have to take half of 48.
Yeah, same height and base as the parallelogram. Would you not agree?
Oh.
Right. So look, this whole parallelogram, right? It fits inside that parallelogram, right? It has the same height and the same base.
Oh, so you just divide by 2.
Yeah, you just divide it by 2. So all you have to do is 48 divided by 2. So it turns out to be 24 centimeters squared. So that one was pretty straightforward. That one, it shouldn't have been that bad if you thought about it a little bit, right? Because look, this triangle, right? It's half of this whole parallelogram, really. Let me erase that. Okay. All right, are we good with A? So A is not too bad, is it?
No.
Okay, let's look at B. B says find the area of BEC. Triangle BEC. So let me show you what BEC is. BEC. Oh, it's this one right here. You see that one? Oops, I don't want to do that. BEC, yeah, this one. Yeah, you see that?
Yeah.
All right, so to find the area of that triangle, it's kind of interesting. What do you guys notice about? Let me do it with different color. This triangle right here, and this triangle. What do you see about those two triangles? Yes, yes, Nicholas. Anything? You see anything interesting about those two triangles?
Well, if you add them up there, one half of the parallelogram also.
Sure. Except we know this is 24 right here, right? The area. So if I add up all three of these area, guess what? It should equal to 48, right? And not only that, we also know something else. Just like anybody? Tony, what do you want to say?
Well, they're similar. They're both similar to the triangle AED also. So they should be similar to each other.
Are they similar?
No, because they have the same.
I don't.
They're just half.
Yeah, I don't think they're similar. But they both have same height. Would you not agree? Look, isn't this the height of this triangle right here?
Yes.
Also, right here, same height, right? Because these two, it's a parallelogram, right? They both have same height. So, knowing that, what do you know about the ratios of the areas of triangles that have the same height? Yes, Michael?
16 and 8.
Yeah, how did you know that this is 16 and 8? Yeah, in other words, what do you know about the two triangles that have the same height? What's the ratios of their area? It's the same as the ratios of their bases. So it's going to be 1 to 2, not 3. 1 to 2, right? Therefore, let's just call this, right? If this is x, let's say the area of this is x. The other has to be 2x, right? So when you add it together, what should it equal to, by the way?
3x.
X equals to 3x, which is equal to also 24, because remember this triangle was 24. The rest of it has to be 24, right? Really? Okay, talk to each other out. It's not that bad. This has to be x to 2x, right? Because the ratios of their area must be 1 to 2, right? Therefore, when you add up these two areas together, that happens to have the ratio of 1 to 2 the areas. It has to equal to 24, right? Because the rest of it was 24. When you add them all together, it should equal to 48, right? Does that make sense? Do you guys want to talk to your group? Oh, go ahead. I'll give you time. Does that? Ask him, see if it makes sense to them. Some of you are still confused. Okay, so we know. Do you guys agree that the ratios of these two triangles, right? The one on the right and then the one on the left, it's 1 to 2, right? So let's say, what if the area of, okay, let's just say the area of this triangle, the smaller one, is 1. What must be the area of the other one? What if this is like 4? What's this got to be?
8.
What if it's x? It's got to be
2x.
2x. That's how I got 2x to x, right? Does that make sense? Because we know that the two triangles have the same height, and we learned last time that the ratios of the areas of the two triangles that have the same height is the ratios of their bases. It's the same thing as the ratios of their bases. So it's 2 to 1. All right, let's look at B then. I mean C. So B is good there. Let's look at C. It says they want you to find the area of triangle ADE. Okay, triangle ADE. Oh yeah, because we just found that this was
16.
this was 8, wasn't it?
16.
And this was 16, right? So that's easy, okay? Because we know that this was twice of this triangle on the left, so that's good. All right, let's look at then. So C was pretty trivial. Let's look at D. D, they want you to find. Oh, this is. I'm gonna put a star on this one. This is the interesting one. CEF, triangle CEF. No, they want you to find triangle CEF, right? So let me erase. Okay, so let me erase these red ones. All right, we want this one right here, this blue one. Is that okay?
Yeah.
Now, who remembers what I wrote as a hint on the website? Yes, Nicholas.
Never mind.
Oh, anybody see the hint that I? Okay, what I said was there's another triangle. There are two triangles that are similar, and CEF is one of them. What is the other similar triangle? Okay, triangle ADE, right? Wait, so wait, is I don't think I wrote this correctly because what is the corresponding vertex of C? It's D, isn't it? DE. Yeah, you gotta say DEA like that, right? Because they have to be corresponding. Anyway, so you know that these two triangles are. Let me do this in red. Similar. Why? Okay, very good question. Everybody, I want you to think as a group. Why are these two triangles similar? Think about it. Go ahead, everybody think about it. That's important. So, do you all see that how the two triangles are similar? Who can tell me? How about, let me pick somebody at random. How about, Kevin? Yeah. Why are these two triangles similar?
Angle.
Yeah, angle. Which angle? So, the two vertical angles, that's obvious. What's the other angle?
The C and D.
C and D, yeah. So look, the two parallel, wasn't this a parallelogram to start with?
Yeah.
You got two parallel lines cut by a transversal. What do you know about the alternate interior angles, guys? Yeah, so by angle, the two triangles are similar. By the way, can I put this A and F? Would that work for A and F?
No.
But you have to extend the A.
Yeah, it does.
Does it work for A and F? Be careful.
No.
It doesn't because look, if I were to use this as a transversal, some of you are thinking this, right? It's this whole angle congruent to, right? It's the other one like this, right? So please be careful. It's not the other. Some people are thinking the other way. All right. Anyway, so you got two triangles similar, and what do you know about the ratios of the areas of the similar triangles, guys? Yes, squares of their scale factor. And what is the scale factor of these two triangles?
1 to 4.
So therefore, it becomes 1 to 4. So you square the scale factor. The scale factor is 1 to 2. So therefore, when you square it, it becomes 1 to 4. So therefore, we know this has to 16. So what must be this? Is it going to be 1?
4.
No, it's got to be 4, right? Because what's 4 over 16?
4.
Yeah, that's so if you put x there, right? Does that make sense? Yeah, 1 to 4 equals to x over 16, right? What is the x? You get 4. So we find that the area of this triangle is 4 centimeters squared. Are we okay with that?
Yes.
All right, let's look. So that was the interesting one. And then once you know D, I think rest is pretty straightforward. Like these are the ones that we kind of did in class, if you remember. Like look at E. They want you to find the area of DEF. Triangle DEF. So where's that? DEF. Okay, so DEF is this triangle right here. Let me do this. Can I erase these?
Yeah.
So let me. Okay. So we said this was 4. All right, and then we want to find triangle DEF, the different color. Okay. There you go. Now look at that triangle versus this blue triangle. What do you guys notice about these two triangles? One person see it? 2? Go ahead, discuss with the group. Everyone should be able to see this triangle. Okay, so I think a lot of you saw it. Both of these triangles have same what class?
Height.
Thank you. They have the same height. Let me do this in green this time. Here. You see this height? Can you see that? Yeah. You see that height? They both have same height. So what do you know about the ratios of the areas of the triangles that have the same height?
The base.
The area, yeah. So if this is 4, what's the other one?
2.
What?
It's 8.
it's just 2 to 1, right? So it's got to be 8, right? If this is 4, doesn't that have to be 8?
Yeah.
Okay. All right. So was that it? Oh, there's F. What's F? No, F says what? BF. Triangle BEF. Where is that? B. Oh, you just add them together, right? BEF. What's 8 plus 4? Okay. Yeah, 4 plus 8 is 12. Okay. There you go. Any questions? Okay. Hey guys. Hello. 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 Guys, did you have a question? Austin? Do you have a question? Do you understand it now? Does this make sense? You just have to add it together. Alright, let's go to the other one, 24. Okay. Alright, let's look at 24. First one, by the way. Class, 24, by the way, don't write on your book. See, that's what happens. Somebody wrote it with a pen or something. Okay, so, A. What do they want? By the way, what do we have, first of all? This is a? Trapezoid. So we know these are parallel. So that's kind of important to know. A, they want you to find the areas of the ratios between 1 and 3. Okay, so, look at 1 and 3. Anybody see anything interesting about 1 and 3? A couple of people, yeah, they are? Very good, because you got the vertical angles together. Again, similarly, you have 2 parallel lines cut by a transversal. This angle right here is congruent to? Can I do this one right here? No, you can't do that because that's not, okay. So these are the, be careful because some people do that and get it wrong. So these are the alternating interior angles, right? So 2 parallel lines cut by the transversal right there. Okay, so they're similar and we know then 2 similar triangles, right? The area ratios of the areas of these 2 similar triangles are squares of their scale factor 5 to 10, which is what? 1 to 2. Always simplify, which is what? Okay, so there you go. The ratios of 1 to 3, 1 to 4. Everybody should have gotten that right. Okay, hey, let's look at B. Doing different color. All right, B says they want you to find the ratios of 1 and 2, right? Triangle 1 and 2. All right, 1 and 2. Anybody? Because it's kind of similar to what we just did, didn't we? Isn't that right? 1 and 2. What do you guys notice about 1 and 2? They both have same height. Good. So they both have the same height right there, right? Don't they have the same height?
Yeah.
So what do you know about the same height? Well, we know that these 2 triangles, right? They have the same height. This one, right, versus this one right here. Right up here. How do you know? Because these 2 triangles fit in this big triangle, which has the height of this. Right? Well, that happens to be the height of the smaller one and also the bigger one. The area 1 and 2 is the height of both, right?
Oh, I see.
Okay, if I were to rotate this, imagine in your head, kind of rotate it, and it's basically this, right? You got these 2 triangles. What's the height of this one on the left?
Oh.
Right here. What's the height of this one? It's the same height, right? Okay, talk to your group. Tell them if you don't see it. So many of you didn't realize, if you have a triangle, how many ways can you draw an altitude? 3. So let me draw an obtuse triangle. Okay, there are 3 actually. So let's say, so this is more important. Let's say that I have thank you. If I have an obtuse triangle, and sure, I could draw an altitude from here to here, right? That's one of them. What's another one? The outside one. So if it doesn't hit, what do I have to do? Extend. So there's another height. Are these 2 heights same? No, they're not. They're not. Okay. And so okay, so then how do I draw the third one? Well, I go like this, and I go from here to here.
Yeah.
So there are 3 ways of drawing different heights, right? And of course, for each of these heights, you have a different base, right? For this height, which one is my base?
Which one?
For this height, H, what's my base?
What is this? No, other one.
This one right here, right? Does that make sense? So don't think that all these 3 heights are same. They're not. Some of you are being confused with that. So hold on. So the reason why I chose this height is because why, guys?
It shares it.
Yeah, it shares with both of these triangles, right? Isn't this the height of this base right here?
Yes.
Of this green triangle? And also, isn't this height of this orange triangle and base is right here, right? Does that make sense?
Yes.
So because they share the same height, I know then the area of the bases, right? I mean the ratios of these 2 triangles that happens to have the same height is going to be what? Yeah, the area of ratios of their bases, which is what? X to 2x. Isn't it 1 to 2 because it was 5 to x, right?
Yeah.
So what do you know about the ratios of these two triangles? It's 1 to 2.
Wait, how do you?
Because I know that this one is, remember, from A, we know that these two triangles are similar by 1 to 2. Right? What do you know about the corresponding size of these similar triangles? They're in proportion. And remember, this was 5 to 10, which is 1 to 2. Right? Does that make sense? Okay, help each other out. If you don't get it, I'll wait. Okay, go ahead. We got, so a lot of you were confused about the altitude of the triangle, right? You could draw 3 different altitudes of a triangle, right? And all these altitudes will be different, right? And some of you say, well, how do you then get the same area? Well, because the base would be different also as you multiply altitude and the base. Does that make sense? All right, so let's look at this. Let's look at C. C says what? What do they want in this one? They say find 1 and 4. 1 and 4, the ratios of the areas of 1 and 4. Okay, so 1 and 4 have, again, same height. So again, let's do the same thing again as what we did. So take a look at this. This triangle versus this triangle. Let's look at the height of this blue one. What is the height of this blue one? If I were to choose this vertex right here, it would be like this, right? And what do you notice about this height? It's same as
The yellow,
the area 1, right? Same as area 1, right? So both of these triangles have the same height. So that means what? The ratio is going to be 1 to 2 again, right? Because we know, remember, from the very first one, yeah, this is y to 2y if you want, right? If you want to do that, okay? Does that make sense? Okay. So let's look at D. Okay, D says 2 to 4. This is the important one. Okay. A lot of you thought that 2 and 4, are these two triangles similar?
No.
Of course they're not, right? The only thing that they do have the congruent angle right there, but none of the other angles are congruent, right? Exactly. So, are these two triangles congruent? No, they're not. How you can't show that? They're not side, angle, side. You can't do any of these. Okay. Yes.
If 1 and 2 is 1 to 2, and 1 and 4 is 1 to 2.
Very good.
It's just 1 to 1.
Okay, so that's a good point. So a lot of you seeing this, you guys saw that this 1 to 2 is 1 to, I mean, right? For B, we got 1 to 2 for this, right? The area of 1 and 2, and then the area of 2 to 4. So this turns out to 1 to 1. Now, there's another way of looking at it. Watch it this way. Okay, so let me erase all this. Okay. Take a look at this. This is the hint I gave. Did anybody see the hint? All right, so take a look at this. Look at this triangle and this triangle right here. What do you notice about these two triangles? They have the same base. Good. They have the same base, and they also have same height, don't they? Don't they both have same height and base? Okay, base. Don't they have the same base and same height?
Yeah.
Well, if the two triangles have same base and same height, what do you know about their area? But listen, but we're not talking about the whole one. But can we just subtract the one that they're sharing, the same exact area? Yeah, because so therefore 4 to 2 is equal to 1 to 1. And lastly, do we have E? E says what? 1 and the trapezoid, right? So, well, we just figured out all these areas. So let's look at these. Remember we said, let's look at the ratios that we have. This was what? 1 to 3 was 1 to 4, right? What about 1 to 2? This was 2, 2. So if we were to compare area 1 with the whole trapezoid, what do you get? 1 to
5.
1 to 1 plus 2 plus 4 plus 2. What is that? That's 1 to 9. Okay. Does that make sense? That's why we get 1 to 9 for that one. Any questions? No. Okay, good.